All right, welcome back. So we're actually going to go right now right into 10.3, which is the dot product. Okay. Ah, I normally should do that before I start recording, but whatever. Okay, so the dot product. Get rid of that real quick. Okay, the dot product. Okay, let's say you have two vectors. Actually, let's start it with dot product. I dotted with I equals j dotted with j equals k dotted with k. These all equal 1. Okay. I dotted with j equals j dotted with k equals k dotted with I equals 0. Okay, and it's commutative. So that means I dotted with j equals j dotted with I, etc. Okay, and that's going to give us the dot product. I want this a little thicker. Okay. All right, so let's see what it turns out to be for just in general vectors. Let's say we're given A1, B1, C1 dotted with A2, B2, C2. Okay, so what that's going to be is that's going to give us A1, A2 plus B1, B2 plus C1, C2. Okay, so it's just, we're just adding up the multiplying each term together, okay, and then adding them up. That's going to give us the dot product, okay? So let's see what that gives us in certain specific cases. Let's take, I don't know, let's say 3, 1, and dot it with 1 comma 0. Okay, so that's going to give us 3, right? Okay. Now, let's take a unit vector. Let's take a unit vector. Let's consider the unit vector in the direction of 3 comma 1. So that's going to be 3 over root 10, 1 over root 10. Okay. So then that one, I'm going to draw it. Okay. Now that's kind of like 3, 1. It goes, that's not quite it, because we're just going to take the unit vector. Root 10, by the way, a little bit bigger than 3. Okay. So my unit vector is going to be basically like so. Not quite so long even. Okay. Not even. Much better. Okay. So what is this thing when I take the dot product of it with 1, 0? Okay. And that ends up being, let me do it this way. We've got a monster here. That ends up being just this length here, right? So that's how you get this idea of the directional cosine, okay? So what's going on, because remember, this length here is 1. So that's how you get this idea of this being a directional cosine, okay? That I mentioned at the end of 10.2. All right, so let's say that I have the vector find the angle that, let's say, -6, 4, 2 makes with the positive z-axis. Okay, there are two ways to really do this, and they're both equivalent. We could either just take the normalization, okay, if we normalize it, we get, let's see, what's our length? 36 plus 16 plus 4. It's going to be square root of 40, 56. Okay, so our unit vector is going to be -6 over square root of 56, 4 over square root of 56, 2 over square root of 56. So the angle that this makes with the positive z-axis is really, we're not finding the angle, but the cosine of the angle. So it's the inverse cosine of 2 over root 56. Okay. All right. That's it for this video. I'll see you in the next one.